our channel. We shall continue with chapter 1, where we're discussing the getting started with TensorFlow 2.0. And today we look at creating a basic image classifier, and we look at how to be able to view your architecture. So we just do all of that. This is pretty straightforward. So we need some libraries. So we need to install the pillow py. So we look at the pillow py, and to import that we just come in here and we import the pillow py. It's already there, so that's the beauty of using Colab. And then the next thing is we use the TensorFlow doc package to plot the loss and accuracy curve. So this library can be installed this way. I'm sure it will be available already now. Okay, it's not available, so it's installing that library. Then the next, it's we follow the steps to complete this image classifier. So these are all the necessary packages that we need to import, so we can just quickly copy all those packages. It says we must restart our runtime, so I won't do that now. Let's see what it does. So we import all our packages. Now we can load our data set. We have done all this before. Because it's MNIST, we expand, we use the label binarizer, we split. So all these are just pretty what we already know. So in just one function we do all of that. Now there is something interesting we're also doing that we didn't do before. It is that we are using the tf.data asset slices to build the data set iterator. So this is another way of building this. So it's going to bundle this training and the label together as just one object. Okay, so you burn the validation together with the bar, just one object. It bundles the X test and the Y test, just one of those, using the tf.data set from tensor slices. That's another optimized way of actually preparing our data for training. So let's build our network now to implement a function that contains our network. So this is similar to Linear 5 architecture. So we've gone through how to build our network, so this is pretty standard, and we're using the functional style to build our network, as you can see. So that's pretty standard. So we define our network in a function, and we can run that in a function and build network. It returns our model. So the next, it's now let's see how to plot what we're doing. And we define a function that takes our model history and our metrics, then it plot them. So this essentially, it uses the Seaborn dark skilled and the history plotter, and we can plot the model history, and we can also save that. So it's very handy for us to use. It's a function that's very handy for us to be able to plot our model, as you will see. So this plot the model history, and we can define the batch size. I really don't know what this buffer size is. Let's see. Consume the training and validation in batches of 256. The prepared spans a background thread that populates a buffer of our image. If anybody knows what essentially this buffer size is, I'd like to know. But then we just follow as it is. So this is the buffer size, and then this one thing here Then we train our network. Now we use the categorical central pillars. We use this metrics. So let's try some other metrics aside accuracy. And I always like to see the bubbles. What's the problem here? I now unpack none of it. If there's something we didn't run. Data set. Where's our data set? Did we run our data set? Yeah. So did you load the data set? And then take the loaded the data set. Yeah, this is load data set. Let's see the function load data set. There's a problem here. I think there's a problem here. So let's load the data set and see what the problem is. So load data set. So let's see, we load our data set. Well, we're able to load the data set, so there's a problem. And that should return the. Did you do any return in it? I guess that's a problem. We did not return anything. We load the data set, but we didn't return anything. So what's going on? Yeah, we loaded it. I thought this should not be a problem. We load the data set, but we didn't return anything. I think that's the problem. There's supposed to be a return function here. This return function should return as a tuple the train underscore ds. You should return the validation underscore ds, and you should return the tests underscore ds. I guess that's where the problem is. So that should return that, so that you already built a network plot. So here where we are now loading our data set, it should return all those. Yeah, so that works there. So the writer of this book needs to fix that code here. They need to fix this code, this particular one, this load data set. So there's a bug here that needs to be fixed. So they're supposed to return those three objects from here as a tuple, just like we have done. Okay, all right, good to see that. So we plot, and then we can now use their code here. We have the buffer size, then we just run it for a specified number of epochs. We've done all this before. Now you will see something interesting here in the in the fitting of our model. We can now use we can store the result in the model underscore history, and we are using, I'm not sure whether it only works with trained data set. I should be sure that it should work with any data set irrespective. Yeah, and in any data set format, that's what I mean, because here we are using the batch, the DS format, the trained or batch that we package it. The way we package our data is a bit different here, so it should work with anyone. Now this. So this is what I mean. So here we're using the tf.data.dataset from tensor slices. That's what we're using to package that. So anyway, we're receiving that as history, returning all the history of our metrics. Then we could try some other metrics instead of accuracy. I have some other metrics that is always being tried. So I normally love to get some more. Let me see if I can define that. So you can define metrics and define a little metrics as it's supposed to be a constant. So you have metrics and you can define a list of metrics like this so that I will remember the format very well. There is some Keras metrics. So you have Keras metrics. So these are some other metrics you could define. Yeah, so this one you could define these other metrics and so you could define this matrix with ABC, give it a name, define this matrix. So there are several other metrics that could be defined there. Yeah, depending on the situation. Classification matrix. I think this is based on binary classification. T-shirt. Okay, so we have the accuracy matrix, binary accuracy, categorical class, sparse categorical. This is accuracy matrix. Okay, yeah, that's what is being used here. So you could experiment with some other metrics too. So let's see. Because I need to get the way they define it. To define it in a list of metrics. And let's start that. Anyway, don't let me spend too much time on that. You could experiment with that and use different type of metrics as you wish and see what that gives you. Okay, so I'll just do away with that. So let's just train for 20 epochs. Okay, so validation is not defined. There's an error there. Train underscore data set. That we get it. Oh yeah. We use val, so this is another bug here. So there's a bug here, so it's actually val. So yeah, so this should work there. Okay. And now our network is training and it's training for 10 epochs. I set variables to 0, so I will interrupt that. Interrupt execution. Let's see variables to be 1, and let's train for 5 epochs. Okay. So once it's done training, we can now plot the training and validation loss. So what this fit returns, it returns training loss and validation loss, and I think it should also return the training accuracy and validation accuracy. Yeah, so it does that too. So to plot the training loss, you just use the function we have defined before. You pass in the model history. What does that function say? Yeah, pass in the metric loss. The y lane, I think, is the y, okay, the region of the y from 0 to 2.0. So the values on the y axis. Then you can do the same thing for the accuracy too. Nothing is passing to accuracy, so it automatically does it by itself. Cool. So let's see for both two. And well, it's taking some time to train. So it's taking some time to train. But while it is still training, let me run this one too. While that is still training, then you see how to visualize the model architecture. To visualize the model architecture, you could use the visualize model architecture, the plot model that we defined before. Plot model is actually imported. We didn't define plot model. Yeah. So the plot model is defined. Then you should note another kind of activation function. This is LU. This is another kind of activation function. We've not seen that up to now. So let's see the plot model. Where did we import it from? So we import it from here. TensorFlow characters with you import plot model. So we can plot them, use that function, and it takes the model, some other parameters as you can see. Then it's also possible to save it to file. You define the name. Then you could also define how you want it displayed, whether horizontal or vertical. Let me quickly cheat and look up that in my other file, my other system, how we actually set the architecture. There's a way we can display whether you want it vertical or horizontal. Let me see that. No. Yes. Yeah, you use a plot model to plot it, and you could say the show shape. Yeah, you could use rank dir. Instead of it to be vertical, you could use rank dir to make sure it is horizontal. So here I can put rank direction, and I can put LR, and that is going to make it horizontal instead of vertical. So you can see that. So instead of coming vertical like this, it will come horizontal. Then we've talked about to save our model before, how to load the model again, and how to evaluate the model. We just use the model, the evaluate function. Then we put in the test data set, and we can get the result. This comes as a dictionary, right? Now, does it come in as a dictionary? The first one is lost. No, it comes in as a list. It comes in as a list. So the first is the accuracy, the loss, sorry. Excuse me, the first is the loss. The second is accuracy. So that's what it returns there. So if we want to load the model, we could load it. But I think we already have one loaded model. Let's see, my system is pretty slow in running. Okay, so let's go to, so let's run this, and we can see that while it is, I can move to something else while it is still running, because I want us to see this. So I can call this model 2. So you can save that as model 2, then we can see the result when it's done. So it's almost done. 4 or 5. Okay, I think that ends for chapter 1. We've seen everything, the basic things that we need to know in how to process images in chapter 1 the different way we can create our architecture and how to use the different way we can package our data set too. We've seen those ones, and we have been able to train a basic image classifier. Let me see if there's anything. We see how to see the summary too, how to save it to file, how to visualize our model architecture. They are pretty good, interesting. So we will continue next time with chapter 2, and in chapter 2 we shall be looking at how to perform image classification. So we'll look at how to perform image classification, and we'll look at whether we should use this data set or not. We might change it. Look at how to build a linear 5 architecture again. We're pretty done how to load this. All this we have been done, so we'll move very fast. And see here they use a different kind of optimizer, which is RMS prop. We also look at creating a multi-classifier for play rock paper scissors. There's a data set for that can detect the rock paper scissors, so it can be downloaded from Kaggle. So we see how to download that data set from Kaggle here. Now this is a way of optimizing this helps to be able to optimize our computation. It's our data optimization. We can define a function here. I can convert our RGB to grayscale, so we see that too. Then let's see what we also go and we create a multi-class where to label watches. This is another interesting one. We may not be able to do all of them, we just pick one or two just to classify the watches. Okay, so you can download the data set from here. And okay, our training is done. Any error? Save model file does not exist. What's the problem? Okay, you can see that this one goes in as what? As horizontal rather than vertical. So if I change this one to this place, I change it here, so it's going to be vertical. You can see that. So depending on your choice of what you want. Load model. Oh, we never saved the model, so we didn't save the model. So what did we call it? Did you say model dot save? And we can save it as model 2 dot hdf5. So that should work. So we save the model. I'm sure it is model we call it, right? Yeah, it's model history, so it's model. So we'll save that, and we can now evaluate on the test data. So what's our result? So we can print our result. So that you do it this way, you just see our result. So the first one is the loss, the second one is the accuracy. Okay, so thank you for listening, and see you in the next one. Please drop any questions or comment below. I will do my best to answer them. Thank you. See you in the next one.